Hi everybody, my name is Matt Lashmar. I'm the Managing Director of MassChallenge Switzerland, and welcome to our first ever MassChallenge convention series, and this is a fireside chat. You may wonder why the MD of MassChallenge Switzerland is leading this discussion, and that's because we have two very interesting partners going to discuss a really cool topic with you this evening, or this afternoon, depending on where you are. But before we get into that, thanks to a few people. Thanks to Nava, we wouldn't be here without you. Thanks to the MassChallenge team, and thanks to the Intera Solutions team for organising this and putting it together. And my job is very simple here. I need to introduce the two speakers, and then I need to get out of the way. The speakers are Stephen DeAngelis, the CEO of Intera Solutions, and Ian Roberts, the CTO of Bula. And they are both partners of MassChallenge Switzerland. And I'm hoping we're going to have a really interesting discussion on autonomous decision science. And the gentlemen will talk and discuss. And if you have any questions, please drop them into the Q&A. I know that Ian in particular will want to drag questions out of the Q&A to make it interactive. And if they're still going by 45 minutes past the hour, we'll stop it and get into the Q&A, but Ian may have done that already. So my job is done. I'm now going to get out of the way, and I will let Ian and Stephen kick it off. Julie, can you bring Ian and Stephen in terms of their images and kick me out?
Very good. So, Matt, thank you very much for the introduction and the opportunity to be part of this. Those who don't know me, I'm Ian Roberts. I also have a huge vested interest in MassChallenge Switzerland as president of MassChallenge Switzerland, and I'm delighted to be joined tonight by Stephen DeAngelis, CEO of Intera Solutions, university professor, serial entrepreneur. So I think an ideal discussion partner for us today. Now, I can no longer see. Stephen, are you in?
I could see you, Ian.
Then lucky you, or unfortunate you, I'm not certain. But Stephen, a warm welcome, and thank you for engaging tonight. Now, I get inflicted upon the MassChallenge community quite regularly, so most of them know who I am. It would be really good if you could give a little introduction of yourself, I think of your past time as an entrepreneur, and then we would move on to Intera Solutions and what Intera Solutions is doing.
Fantastic. Thank you very much, Ian. So my name is Steve DeAngelis. I hope you could see me. I could see Ian and the rest of the group. I am an entrepreneur. I just want to make one little correction. I've been a visiting scientist at a number of universities. I never had the opportunity to be a professor, just to make sure my university colleagues don't get in trouble.
One webinar with me and you'll get promoted, I promise you.
But the interesting thing is, I've been fortunate to have a career as a serial entrepreneur that has spanned companies in the manufacturing industry. I was a CEO of a chemical manufacturer, then a dot-com era supply chain optimization firm, and then a national security contractor in the area of enterprise resilience management. And then today, for the last 11 years, building and running Intera in the autonomous decision sciences space, which kind of leverages all of the accumulated entrepreneurial activities along that journey. And at the same time, again, I was lucky enough to be a scientist at a number of universities as well as national laboratories. So Intera sort of sits at the intersection of the government, academia, and the commercial sector. So hopefully we could bring some of those experiences to bear today to have an interesting conversation, as Ian and I and Matt have had in the past. So I'm looking forward to the conversation today.
Very good. Now you've been working at using this autonomous decision science approach, and maybe before I ask about use cases, it might be good just to explain why this is different. I mean, I find the whole world of AI, machine learning, data science is full of acronyms, and sometimes it's quite difficult for us to understand which one, what's the benefit of which one, and where autonomous decision science sits in that range.
Sure. So, it's funny, a lot of people ask me, what does autonomous decision sciences mean, and how did you come at autonomous decision science? And so maybe I could explain it through the lens of how we came to it, and then what it does today. So when after September 11th, we worked in the government sector, colleagues of mine, the predecessor entity to Intera, helping the government build resiliency capabilities for governmental agencies and critical infrastructure in the United States and elsewhere. And one of the things that we had to do there is we had to process vast amounts of data, generate meaning from that data, and then make a decision, oftentimes within a decision cycle that was in very quick periods of time, minutes, hours, days, not, in rare cases days, but minutes and hours. And the notion was you needed to be able to ingest data, make sense of it, generate an insight, make a decision, and then learn from that insight, all within a rather confined timescale. So one of the things that became apparent quite quickly was that you couldn't do this manually. You needed to gain leverage in technology in order to make that happen. So one of the things that we had done was we came across a series of technologies and capabilities as we started to try to address the requirements for resiliency. And those requirements sort of led us to integrating two worlds of technology and analytics that have previously been in separate worlds. The area of semantic reasoning and symbolic logic, and in the area of mathematical analysis of data. And, like in any industry, people have skill sets that they learn. So when we first came to the space, we found that the people that were in the human-like reasoning camp, which previously was called expert systems, people like that believed that every nail was hit by the semantic reasoning and symbolic logic hammer, right? And the math people, the statisticians, the machine learning folks thought that every nail was hit by the math engine hammer, right? And the notion was truth be told, you needed to combine both capabilities in order to get scalability and elegance in the system that was necessary to process the vast amounts of data that were at our disposal, but we didn't have the analytic techniques to process quickly enough. So we came at ADS through a journey that started in the government sector, involved both research that was done at Carnegie Mellon Software Engineering Institute, research that was done at the Oak Ridge National Laboratory, research that was done at Princeton University. Combined that with practical work in the government and the commercial sector to build a capability that had build a technology platform, rather, an ADS capability that had three core attributes to it. So the first was we needed to be able to reason in a human-like fashion. The second piece was we needed to derive knowledge from the mathematical analysis of data, but in a non-black box way, right? So we needed to have a glass box explanatory AI, and we needed to perform real-world optimization or nonlinear optimization that allowed us to optimize things according to a goal state, but do it in a way that reflected the richness and complexity of the real world that we operated in. So what we did was ADS as its core bridges the gap between semantic reasoning and human-like reasoning and the deriving of knowledge through the mathematical analysis of data in one platform. So ADS is autonomous decision science. Think of it as the next step of the journey of data science, where the AI that's not defined as a machine learning algorithm, but AI that's a human-like reasoning AI, plays the role of the data scientist, plays the role of the subject matter expert to provide enterprise scalability in the analysis of data, the generation of insights, the making of a decision, and the learning from the efficacy of that decision. So ADS, again, we defined it as human-like reasoning combined with glass box, transparent, explanatory machine learning, plus nonlinear optimization. And the notion is, if you posit that those capabilities exist in one platform, you could design solutions to the market that are otherwise orthogonal to the way that solutions have been built previously, because you have different tool sets with different capabilities. But that's a little bit of the story of how we got to ADS in a journey from the government to the commercial sector, blending academia, the government, and commercial sector requirements to build a platform that met the requirements. We didn't seek out, Ian, to build an ADS platform, and we didn't even know what ADS was. We saw a set of requirements that we needed new tools to solve, and we invented the tools and brought the tools together to help solve that into a unified platform.
Now, I think you summarized it beautifully, and it's the bit at the end that resonates to me. It's about creating the capability to solve problems worth solving.
Right.
And I think this is really important. And so is it possible, I mean, obviously everything that you've done with government and security, it's not possible to talk about. But do you have some examples of how this works to solve problems, perhaps in the food value chain or in the commercial sector, that you're able to share? Because I think that makes understanding a little bit easier, doesn't it?
Sure. I mean, absolutely. Look, so today we live in a rather uncertain world, right? So there's a lot of change going on. In 2020, we were helping large global consumer products companies navigate COVID. In 21, it was COVID plus the effects of inflation. In 22, it's COVID plus the effects of inflation, plus geopolitical uncertainty coming from the war in Ukraine. And all of that, and when you add to that, the more macro challenges of climate, natural disasters, stuff that happens all the time, like blockages in the Suez Canal and things that happen routinely. Companies live and operate today in a rather uncertain world, right? I mean, Bueller is at the epicenter of a lot of this as the world's largest grain processing machinery company. And the notion is that when you look at that level of complexity, right, you need elegant tools to solve the problems. And one of the things I forgot to mention in the lead up is that the area of science that we're involved in is called the complexity sciences. And it's really the analysis and control of complex dynamical systems. And ADS is a platform that helps analyze and control a complex dynamical system. So the food value chain and the major players in that value chain are a large complex dynamical system that when there is an external stimuli, like changes to consumer behavior or changes to supply chain challenges, or the things we mentioned earlier, macro effects like inflation and geopolitical uncertainty, you need a technology that allows you to address those things systemically. Because when we were building resiliency systems in the government, we posited, Ian, that we were never going to be able to identify a priori all of the potential threats and vulnerabilities. But if we're so good at responding to them, then we can mitigate risk and we could exploit opportunity, right? So today, I think the global food value chain is being affected by these system shocks. And leading companies and governments need to be able to be agile and resilient to those challenges in order to play a leading role in the market to mitigate risk, exploit opportunity, and provide food to people who need to have food provided to them. And so it is, But in order to do that, we need these types of capabilities in order to respond quick enough to navigate a very, very uncertain landscape. So that's sort of like a little bit of a macro framing of the food supply chain problem. And there's, we could talk, I'd love to chat about where, what your perspectives are and how we can align technology against some of the challenges, but there are, numbers of challenges to the global food supply chain today.
Yeah, I mean, I think to give a perspective, it is one of the topics that beyond being my business, I think now keeps me awake at night. If you look purely at the greenhouse gas footprint of the food system, it's about 25% of the world's greenhouse gases. If you look at freshwater usage, it's about 70% in the food system. Energy consumption, it's around 30%. And then approximately a third of food is lost or wasted due to inefficiencies in the supply chain. And be that in consumers' homes, because we're not very good at managing best before dates and sell-by dates, or be it actually lost pre-stabilization in value chains in developing countries. So we come from a situation where there's huge pressure there because we have a food supply chain that is not fit for purpose to feed, the citizens of the planet at the moment. But then on top of that, with population growth, we have the huge pressure on land. So we need to feed 10 billion people in 2050 using approximately 30% less land, and that land needs to be set aside for biodiversity restoration and carbon sequestration. So there we've kind of got the climate crisis, the biodiversity crisis, and in order making sure that we have a big enough role in eradicating poverty, that the poorest of the world can eat well, and we can close that gap in wealth that is growing and causing a lot of geopolitical tension. Now, on top of that, we come out of the biggest pandemic we faced. And now with the war in Ukraine, you have 30% of the world's grain supply in Ukraine and Russia. And the people who will suffer the most are those that have no role in the conflict, which are Northern Africa, Middle East, and these areas where the food supply is reliant on the region currently involved in the war. So this leads to a food scarcity question, particularly in Europe and definitely in Africa, Middle East. It leads to an energy scarcity question. That's not one I thought we would experience in our lifetime in Europe. And so I think there's big questions about the efficiency of the existing food value chains and the capability or the resilience to respond and remain stable in the face of such perturbations as we face today, such as the war in Ukraine. Now, I would love you to be able to solve all of that, obviously, but clearly an unrealistic ask. But I think there's aspects of it in how do we make our food supply chains more resilient that are very important to look at, given the number of external factors that are influencing it today.
I think that's a great summation. I would agree with everything you said. It's also an ethical issue, right? You mentioned, the people who have the least ability to be resilient are the ones that are immediately most affected by the war in Ukraine. And so I think that, you have to think globally, act locally. And I think leading companies who are North Stars in their ecosystems are going to, I think it's going to be a combination of government and commercial sector entities. And the world, to a certain extent, while looking at being resilient to protect your own population, also realize that this is a very small planet and we all act very cooperatively in the butterfly effect. We have a wave of the wing over here, and there's a system perturbation or cascade over here. And I think, we have to realize that we have to make the supply chain like you say, fit for purpose. We need to be able to extract grain from Ukraine overland in case we can't go by water anymore, right? We need to build capabilities where we build silos in places where, as we bring grain over from Ukraine into Poland or someplace else, there are silos to handle that transshipment out. But we also need to be able to look at issues like decarbonization, issues like alternative proteins, issues like, when I mean alternative proteins, plant-based proteins that can be manufactured regionally, that can, take some of the pressure off the system regionally if there is a global shortage like in grain and something. So the notion is, I think we need to think of this as a system. Large companies are already, leading large companies are already building resiliency models into their organizations because they know that this latest round of uncertainty is like other rounds of uncertainty they have faced in the past. Maybe more, we have data at our disposal today that we didn't have before in other large system shocks. And I think if we could align the value chain such that it is more nimble, it is more agile, we have regional manufacturing that breaks the dependency of some of the globalization supply channels, but at the same time allows us to think holistically about the fact that we all live in a large system and we need to be cognizant of that. I think, we can make that happen if we're responsible actors. Now, in order to do that, we need to be able to get insights into how to actually do this. And it drives, product innovation. How do we develop sustainable products? How do we price and incentivize the market to possibly move from products they make today to these new, more sustainable products? And how do we make the supply chain resilient, not just redundant with redundant suppliers, but how do we make it systemically resilient where there's multiple channels to get product from point A to point B? We anticipate some of these challenges, and we provide for alternative mechanisms to get product to market through raw material to manufacturing to market in a way in which we're not dependent on one or two main supply chains. So, I think it's a different thinking. It's almost thinking of your business and your nation state in a local way and in a global way. And, thinking of it as a dynamical system that you want to be able to analyze and control the most effective way of building a resiliency into it.
So one of the things we've touched on briefly in the past, and thank you very much for the answer. And I'm not going to try and push you in a webinar to solve the global, should we say, conflicts and peace issues. So one thing we talked about, and you mentioned it there, when you talk about decarbonization, it is the need, or let's say the current move at the moment to plant-based proteins, to more sustainable proteins, and obviously the need for us in Western society to temper and change our diets. I think it's interesting to combine that with the need for domestic protein supply, as the global supply chains are are going to be less reliable and less resilient, and certainly less predictable. Do you see a role for utilization of ADS in how we formulate products, in how we create products that are particularly tailored to local taste?
I think there is so one of the things that ADS is effective in is the ability to perform formulation, whether it be drug formulation, food product formulation, and pharmaceutical formulation in a way that you could formulate a product to the performance characteristics that you would like to have the product. So if you have a plant-based burger, when you cook it, you want it to have a certain set of crunchiness on the outside and texture. You want it to emit a certain form of aroma. You want it to have a certain amount of nutritional attributes to it. So you want to formulate that product, right, in a way for the performance characteristics that are optimal for the design. But you also want to be able to create a sensory experience where the taste, aroma, and texture of that is very pleasing and attractive to the end user. So ADS, the glass box machine learning part of ADS, allows you to bring both data from the product formulation side and data from the sensory science side into one sort of one brew or one data set where you can analyze that, derive the control variables, and determine how do we adjust the formulation of that food product or that pharmaceutical product, right, to meet both the performance characteristics, and in the case of food or things that relate to flavor, aroma, texture, you can design it to be both performance and have sensory attributes that are desirable for the end user. And if you could speed up the historic design of experiment process, and you can iterate on the ability to formulate and design these products quickly, you'll be able to formulate sets of alternative protein-based products or plant-based proteins that would be meeting emergent market needs. Both, you have a global platform that allows you to formulate the product and maybe change the taste of the product to meet local needs, local culture, local taste desires, right? And I think that ADS is a way to do that faster and with a higher degree of accuracy than the traditional design of experiment process.
Mm-hmm. And I think, I know you talk from a position of experience here because you've done this with pharmaceuticals, and I don't know if you're able to share generically your experience there.
So let me give you an example of both on the flavor side and on a hypothetical pharmaceutical example, and then we'll show how they combined. Okay, so in the drug formulation area, drugs are formulated. There's a lot of data. Let me give you an example. We got a data set once from a pharmaceutical company, a model data set that for a drug that couldn't be formulated, had trouble being formulated, meeting all the FDA and EU guidelines for formulating the drug. And the notion was the place gave us the company gave us a data set. It had a couple thousand variables in the data set by, say, 6 million rows of data. Think about a spreadsheet with a couple of thousand columns and a couple of million rows. And the notion was, how do we formulate that drug according to the constraints that were necessary in order to optimize that particular drug? So in this particular example, ran it through a math engine, we found that there was a 7 manifold or a 7th order combination of variables. Only when those 7 come together, they describe 84% of the variation in the data. And the notion was that with that primary interaction of these variables, and in secondary and third level interactions, we could describe another 9%, roughly. So you could really describe about 93% of the variation in the data through the interactions of 7 out of a couple thousand variables. Very big deal, because the other ones fell, the 1983 93 fell away as noise, and these 7 were the ones that you needed to focus on. You isolate the effect of each one of those. Variable 1's responsible for this, variable 2's responsible for that, and so forth. And those variables become control knobs in an optimization that will allow us to satisfy the constraints, the competing constraints for formulation, through the turning of the control knobs to maximize that objective function, which was to make that drug shelf stable. So, and what we found was that we could get to an efficacious outcome with 3/4 less experiments than if we did it in the traditional design of experiment process, right? And in the pharmaceutical business, I'm rough order of magnitude, I'm probably going to be wrong in the exact number, but it's about $1 million a day cost to develop these drugs, right? Or formulate these drugs. But that's not even the advantage. The advantage is getting the drug to market faster. So think about
Yeah,
COVID.
exactly.
COVID's created, COVID comes out, there's a race to formulate a drug. If you can bring it to market quicker, right, through the advanced, reliable glass box mathematics, you can prove you can get to a smaller subset of experiments necessary to go through the actual experimentation process by eliminating 3/4 of the ones that got you there in the first place. So the math can get you there faster. If you think about that and conceptualize that, and then on the other side, the same mathematics and artificial intelligence can think about creating a unique identifier for the way that every product, ingredient, and recipe tastes from the taste, aroma, and texture perspective. So think about a recipe like chicken parmesan. It has chicken, it has mozzarella cheese, it has tomato sauce, it has various, garlic, various other spices that go into it. Think about creating a unique identifier for the way that every ingredient tastes in a multiple dimension. So we built a system for a large spice company that had took 3,000 dimensions of taste, aroma, texture, boiled it down to 55 core ones. Those core allow you to create a dimensionalized space for the way that every product, ingredient, recipe tastes uniquely. And then you marry, and then if you think about combining that, and then when you combine those ingredients in the cooking process, according to culinary science, there are culinary science rules that show how products combined in flavor through the cooking process, and then they can create a consolidated taste at the end. In other words, onions taste a certain way in their raw state, and a Vidalia onion is different than a Spanish onion, which is different than a green onion. When those are cooked according to a prep method, they transform their taste. So if you think about creating advances in food-based formulation from a sensory perspective, you combined the capability of drug formulation or food-based product formulation with the sensory attributes, you could bring those together to greatly innovate and greatly expand the product innovation process in the global food chain, and make products locally out of alternative proteins that would de-risk the supply chain that otherwise has grain coming from Ukraine or other places. And if you could use it as a de-risking factor to make satisfying products that are well formulated, that are designed locally and made locally, you could act locally while thinking globally.
So I think it's a really good example, and what we see, and it's just been highlighted in one of the questions that came in, and I think the food industry is suffering from this, is the input costs to produce products are increasing rapidly. And obviously then the retailers are extremely reticent to increase the price. So the ability to pass on the input cost increase to consumers is low. And as we go into recession, that's not going to increase either. So based on your logic, you could, I'm assuming you would imagine that you could accelerate the product development to utilize more local ingredients, but also to cost optimize and deliver the same output.
Absolutely. I mean, the notion is when you think about a supply chain and you think about moving raw material suppliers from one supplier to another, and those suppliers move from country to country or place to place due to climate change or due to other requirements, there are costs associated with that switching. There are manufacturing differences in cost, there are logistics costs, there's transfer pricing issues, there's n number of different costs associated with navigating that. If you're able to do this more locally, you can eliminate a lot of those costs and be as optimal in the way that you design your supply chain to meet the products that you are seeking to manufacture. So I think that operating, being able to truly model your supply chain, understand where your core raw materials come from, how many you can make, how many you could supply locally, how many need to be brought in internationally, where the resiliency in the supply network is, and what the cost of switching from one supplier to another in terms of cost, logistics, time to market, quality of the product, sourcing of the material from non-conflict zones and risky places, are things that all go into the alchemy of how do we create an algorithmic approach to understanding how to optimize and design your supply chain, and then operate in a way where you're managing your inventory as effectively as possible to lower the structural operating cost, because you're able to manage the demand that you have coming from changeable consumer preferences with the supply requirements that need to come in to manufacture the products that are reflective of that changeable landscape. And that is something that is, it requires a little bit of deftness of analysis to be able to handle structurally. And one of the things that we found during COVID very practically and during inflation was that if you could use demand shaping capabilities, Ian, to modulate demand. So let's say, for example, we have excess inventory of product X, right? And we thought that consumers were going to have a certain amount of demand. We have excess inventory. We can incentivize inventory purchases by toggling up demand by increasing trade promotions on those products. We could dampen demand if we don't have supply by dampening demand by taking away trade promotions and making the product slightly more expensive. So the notion is you can manage supply and demand through the levers of revenue growth and through the levers of supply chain. But being able to manage that and balance that requires a degree of skill and analytic capability that ADS is fit for purpose.
Very good. Now, all of this, I mean, obviously, then begs the question: if we could come in and we could fix this, cost optimization on input costs, for example, which is a very hot topic at the moment, whilst giving the same product quality, being compliant, etc. What type of data and data structure does the company need for this? Because my experience has always been, we come up with a really cool approach, and then we spend years trying to clean up the data to be able to actually execute and extract the value.
Well, so obviously the question on data is driven use case by use case, business application by business applications. Let me talk about the revenue growth levers first. On revenue growth and being able to use the tools of revenue growth to drive sales. Typically, consumer products firms that have quote unquote modern trade. So that is consumer products firms typically in North America, Europe, places in modern Asia where they have data. Modern trade is defined as having sufficiency of data and the ability to have retailers who can engage with consumer packaged goods manufacturers to execute these trade promotions.
You need a relatively consolidated retail base that's pretty sophisticated.
Well, not basically sophisticated, right? And so a large swath of the world uses modern trade, right? And the notion is syndicated data sources like IRI and Nielsen and others have in market already mechanisms of gathering retailer data, harmonizing that data, and putting it into a reusable format. And consumer products manufacturing firms buy that syndicated data in an organized fashion from those syndicated data sources. They also need order data that typically comes from that they have organized within their company. So whether it be in a system of record like SAP or Oracle or other transactional systems of record, Salesforce, they're able to bring that data together. And whether it's in a data lake or or something where firms like ours bring that together for them, that data goes into a data model, which then fuels the analytics engines of the company, gets transformed into a model, and the model fuels the analytics capabilities of the business. And so you need syndicated data, order data, transactional related data, your logistics information, but most of that data is at the disposal of companies. Now, is it organized? Is it completely clean? Is it very well put together? It's never perfect, no matter what company it is. are degrees of maturity, right? From highly mature to low maturity, but the data is accessible, right? On the supply chain side, it's oftentimes order data and logistics and manufacturing and warehouse inventory related data that come again from your transactional systems of record. There are external shipping source information and others that are available. So in these particular use cases of revenue growth, demand planning, and supply planning, the sources of data are known and they're available. How well organized they are at a company is another story, right? But the data is available. So if you bring that data together and you do it in a focused way where you're bringing the data, think of the data as the rocket fuel necessary to fuel the analytics engines, right? You could design it in a way that is in scope and fit for purpose for the insight that you're seeking to do, and then use that to perform the analysis. But to answer your question specifically, the data that is required is standard, it is available. How well organized it is, like I said, at companies is a different story, but it's available. It's not like we have to invent or curate new forms of data. These sources are already available today.
Okay. Now, some of these sources, obviously, you have to pay for, and I can see with big companies and who have well set up data management systems, whether they be on SAP or other well-recognized brands. I mean, they have kind of this structure. I'm wondering now, and to bring the conversation down to startups and small companies, and obviously you have a high interest in startups. You've been a startup, you've been an entrepreneur, and you've joined MassChallenge with the perspective as well of being able to use your skills to support MassChallenge and the startups they accelerate. So what would be your advice to startups to be able to take advantage of things like ADS on their journey to accelerate their development?
So, I mean, one of the things is that ADS is an enabling platform. So if you don't have to reinvent the same fundamental platform, and you could build on top of that, it could leapfrog your getting to market very, very quickly. So, you know, firms like ours or others who invest in platforms invest tremendous amounts of money in a fundamental platform that enable a set of business applications. If you could use ADS capabilities to build applications on top of the fundamental platform, much like people build applications on top of Apple products or build foundational products on top of every major platform, think of ADS as a platform that you build applications on top of, that you don't have to reinvest in the fundamental technology that built the platform in the first place. You could leverage it to build unique applications that sit on top of it and leverage the underlying platform, which could get you to marketplace a lot faster than if you were going to build it yourself.
That's very cool. That's very cool.
Which often takes a lot of time and money, and usually you have to justify that to a venture capital provider who usually is very particular about how they view costs associated with those things.
Very good. Now we've opened up to questions, but we have one question from. Let me take this before we get questions from our friends. Could development of these new resilience built models be taken on by the World Economic Forum as world insurance? Maybe step by step, but I'll let you have a stab at that one.
I thought you were going to take that one.
Well, he said could, not should.
Yeah.
I would say should, yes. Could, I leave the practical part to you.
I think that, well, I don't know about the World Economic Forum's, exact mission, but in this aspect, but I think that models win, right? If you developed a well-organized model and the model is focused on a particular application, it's not trying to be all things to all people, right? The notion would be that you could model out resiliency for certain portions of the global food supply chain and understand what the potential, who the potential threat actors are to that, what means of attack could a threat actor use, what countermeasures, what threat outcomes and impacts would come from that actor using that means of attack. And the notion is you would be able to model out how to build resiliency into the global food supply chain, section by section. And I don't know about insurance, but the notion is you can model that out. And you can model it reliably as long as you constrain the model space to something that is feasible. Now, the second question is, could this been involved in the metaverse? Could you use the metaverse to model this? I think the metaverse is going to be a evolving technology that will allow for a rich immersive simulation environment. It's not the only capability, but it is going to be one that you could use as a rich immersive simulation environment to look at all the potential threats and vulnerabilities to the food supply chain and develop scenarios to mitigate risk and to exploit potential opportunity for good. And I think that it is a great application of the metaverse as the metaverse matures into an industrial scale capability.
Very good. Now I see, I saw a question from Nava, who I think she's been dying for me to ask you this question throughout the discussion. The future of AI, what's the next step?
Well, I think ADS is a part of the next step of the journey. AI is moving inexorably. I don't know how fast, but inexorably towards an artificial general intelligence. Today, ADS is a step forward where you blend semantic reasoning and symbolic logic with, and all of its benefits in human-like reasoning, where you use mathematical logic to forward chain. I want to beat you in chess. What steps do I need to play in order to beat you in chess, given the moves that you make? That's abduction. Deduction is I ate a piece of cake. What predicates did I have to solve in order to eat a piece of cake? And if you use backward chaining and forward chaining of logic with large knowledge bases like ontologies that have both common sense knowledge, industry specific knowledge, functional specific knowledge, in a knowledge base, it's kind of like the hard drive in your brain that you're able to reason against. If you combine that human-like reasoning with the mathematical analysis of data, both in glass box mathematics, high-dimensional mathematics, as well as machine learning capabilities and deep learning capabilities, with the ability to optimize, I think that blending in an ADS is a next step. But as neural nets and human-like reasoning get more mature, we will move towards this artificial general intelligence, and we'll be able to, create new capabilities that were subject to science fiction 20 years ago, that are now coming into science, and the fiction part is dropping off. And I think that if we move towards that in ways that don't build in bias, that are reliable, that don't involve garbage in, garbage out type of analyses, then I think it's going to eventually move towards a artificial general intelligence.
So I think just as the perhaps the final point, because I see we're running a little bit out of time now. You're obviously there and geared up to tackle big problems. What are the preconditions for somebody who's coming to you and has interest in working with you to tackle issues? What are you looking for?
The biggest precondition is alignment of the business players. So if you have business cases that need new capabilities to solve in a generationally more advanced way, that is a major precondition, is the identification of business use cases that are transformative for the company. You have to align the leadership of the company, both from a business perspective, analytics, IT perspectives, as well as subject matter experts. Align them in towards the goal of the business case. You get senior sponsorship, and you build steering committees that have representative members of those organizations, and you develop practically applicable tools for the transformation of the business. I think that those are the attributes of the projects. It's got to be grounded in that, by the way, drive return on investment within the first year of operation, because companies want to see ROI, they want to see alignment of interest, they want to see initial sufficiency of data, and they want to see business cases that, if you're successful and you create a virtuous flywheel of profitability, you can land and expand to other applications from a point of credibility within the organization. So I think you have to be very careful in setting up the use case for success.
Very good. Look, Stephen, it's been a pleasure to talk to you. There are so many opportunities and so many things that we could try and apply this to. And I think it's exactly as you say, it's about finding concrete examples that you can multiply, that you can scale, and can prove the value quickly. And by scaling them subsequently, we bring the impact that we look for.
I mean, practically speaking, Ian, we have found that if you focus on growth applications versus cost containment applications, growth trumps cost containment, right?
Interesting.
So we have found a very interesting observation that growth trumps cost containment, because folks posit that they could always cut costs, but growing an organization organically, right, is more difficult. So if you can find business cases that are growth driven, that drive a solid return on investment, that, by the way, that return on investment is clearly measurable. So there's no ambiguity of whether you're successful or not. It's not an art project, it's more of a science project in the measurement. And you align the teams, then I think you will be able to, drive growth. And these kinds of capabilities where there's transparency in the analysis, where there's a glass box explanatory nature to it, that don't require someone to trust the black box, builds trust into the system. That was one of the key things I should have mentioned earlier, is that ADS by its nature is transparent. It explains what is going on within the system itself and how we're controlling it. And people tend to trust systems where you could explain to them what's going on and say, Ian, here are the control knobs. Here's how those control knobs work. Here's cause and effect. Knob, this outcome happens. And by the way, let's do it. Let's experiment with it. Then let's measure and let's see if the outcome equals the forecast of what that is. And if it is, and you can see why it happened, you generally build trust into the system, versus a system where it's like, wow, there's just some magic happening in this box that we can't explain to you what's going on in the box, but just trust it, right? Companies don't like that. They have the ability to truly introspect the system and find out what's happening.
Very good. And I think that's the point that we will close on. Stephen, thank you very much indeed. It's been great to talk to you. It's great to have you as a partner of MassChallenge.
It's great.
I think it's such a super contribution to the knowledge and pool that we have to support not only the startups, but also all the partners of MassChallenge. So thank you very much indeed. And I will hand over to Matt.
Ian, thank you very much. Stephen, thank you very much for demystifying and also making it very pragmatic. And thanks, audience, for some really interesting questions. So that was the first in the series, the Challenge Convention series. The next one coming up is going to be on climate. So look forward to seeing you for the next discussion. And I'll wish you all a good evening. So thank you, Ian. Thank you, Stephen. Thank you, Entera team. Thank you, MassChallenge team. And thank you, Napa, for connecting us. Good night, everybody, and good afternoon. Thank you.